Hi students, welcome to Food Feeds. So this is the second video of Junior Analyst. So in case if you haven't watched the first video, go and watch the first video. So we have discussed some important MCQs in that. Okay, so let's start the second video. This I have already explained in the last class that this is going to be an explanation video. So basically this second chapter considered to be a really tough because of two reasons. One is this is relatively a new topic. Right, this second chapter is a new topic, so for that reason there is a low shortage of materials. Okay, so there is a low shortage of materials. So based on these two factors, many people consider this to be a toughest topic and they usually skip the topic. But we Food Feeds thought to break that. This is a really important topic. If you want to skip it, don't skip it. Please study this topic. I will explain this topic in detail, and if you want to study it in much more detail, then I will give you the PDF to study this topic. Okay, there are basically three PDFs you have to study. So the first one is the FSSI PDF. FSSI manual is given, so you have to study that PDF. That PDF will be given you in the Telegram channel, so go and find the link for the Telegram channel in the description. So the second PDF which you have to study is GLP, Good Laboratory Practices. That will also be given you in the Telegram channel. And finally, the last and important PDF which you have to study is ISO 17025. Yeah, along with this you have to study two regulations. Okay, there are two regulations which is related to laboratory, so you have to study those regulations. Plus you have to visit some websites to study some basic detail about NABL, ILAC and APAC. Yeah, so these are the materials to study for this chapter 2. Okay, so if you have studied all these materials, then you are probably good to go. Okay, so let's start the chapter. So yeah, so this chapter, what I have done is basically I have divided this chapter into three parts. The first one is setting up a laboratory, and the second one is accreditation, and the third one is laboratory safety. So in the first one, setting up a laboratory, I have divided this further into two topics, which is part A and part B. First, let's study the part A. Part A is a really simple concept. Okay, let's study this. Why we need a laboratory? Okay, this is a really important question which we need to answer. So basically, why we need a food laboratory? Because of microbial hazard and because of chemical food contamination and its hazard, right? And not only these 2 points, the third important point is we can see that there is a rapidly changing technology. For example, novel technology has been recently emerging and changing, and we can see, for example, GM foods, which is a really recent important technology which has happened. So in order to test whether this GM food is good or bad, we need to check it. So how to check it? Using a laboratory. So that's why we need a laboratory. Apart from these hazards and contaminations, we need to check and we need to assess the rapidly changing technology. Simple, right? So next question, what this laboratory can do? It can do various things. There are three important points which I have mentioned here. The first one is it deploy a wide range of analytical techniques. Okay, so these analytical techniques will be used for food regulatory system, right? So basically, which means it will do some analysis. That's it, simple point. And the second one is these analysis will be done in a timely manner. What is a timely manner? We already know that for a food analyst, if they wanted to check a product from food analyst, then he has to do the analysis in 14 days. So that is a timely analysis, right? So we can easily use this timely analysis to check the surveillance and enforcement, right? So these are the two important points, and the third point is really important because we can check whether this product is linking with the domestic standard and international standard. So we can easily check three things. One is we can check for the analytical techniques, and we can go for timely analysis, and finally we can compare with the international standard and domestic standard. So these are the roles of food testing lab. Okay, Now combining all these like roles of food testing lab, we can say this is an expert system. Okay, because it is a silent model. Okay, we will only use it when we need it. Okay, it is an expert system. This will ensure the safety and quality of food. Okay, so to ensure the safety and quality of food, what is the requirement of food testing laboratory? Okay, what is the requirement of food testing laboratory? So we can say infrastructure, facilities, equipment, supplies and reference materials, which we have said here, international and domestic standards. These are considered as a reference materials, right? And to access the calibration and operating under international quality assurance program. So these are some basic requirements. And apart from these requirements, we need a really important person who is a food analyst, who will be well qualified, trained, experienced, and should be have integrity, and he will be well with the management. So this is the second point, and the final point is obviously accreditation. He needs to get a formal accreditation. How to get accreditation? He has to get these two things. In order to get accreditation, he has to establish an internal quality procedure. So yeah, okay, so what is this internal QA procedure? Which is nothing but quality assurance program. For example, whatever process or procedure you are doing it will be checked whether it is done in the quality or not. Simple. And the second one is laboratory proficiency testing. This proficiency testing is done by many industries. For example, for the like in case of, let's take an example of India. In case of India, QCA, and under QCA we have Nabl. See, who will check the laboratory proficiency testing for Nabl? It will be checked by APAC, okay, or ILAC. So they will check the laboratory proficiency testing. In case of a laboratory, let's say in case of a food testing laboratory in India, Nabl will check the proficiency, lab proficiency testing. So yeah, so that's how the PT schemes will work. So this is ultimately called as PT schemes. So combining these two attributes, we can say a lab is accredited. Okay, this ensures the quality of results. Okay, this point is really important. These two important procedures which we need to do in order to get the accreditation will ultimately ensure the quality of results. Okay, so we have already discussed here that it can do a wide range of analytical techniques. Now let's see what are the analytical techniques. There are 4 important techniques. The first one is the general parameter. As we can see, most of the parameters which is general. Okay, so alkalinity, acidity, moisture, total ash, and all those things. And the second one is nutritional parameter. We can see many nutritional parameters has been mentioned here. See guys, energy value will come under the nutritional parameter. And the next two is self-explanatory. First is food additives and contaminants. Obviously additives will be mentioned here. And the next one is the microbial analysis. All the different TPC and other plate counts will be mentioned here, right? So these are the 4 important parameters which we need to carry out in order to have a basic food testing laboratory. Okay, but here is an important point guys. Determine the investment and space needed, which means, see, these parameters which we are going to establish in the lab, you will be establishing either the second one, or the second one and third one, or the second one and fourth one, which means whatever the analysis you are going to do, according to that analysis, the investment and space will be needed. It's a simple point, right? But there is a twist. All the laboratory minimum requirement of a food testing laboratory should be the proximate analysis. If you are telling that your laboratory is a food testing laboratory, the word is really important. If your laboratory is a food testing laboratory, then nutritional parameter, which is also called as proximate analysis, okay, which is also called as proximate analysis. So this nutritional parameters, which is also called as a proximate analysis, which is the minimum requirement in order to have a food testing laboratory. And other analysis you can, if you want to add, you can add, obviously that require high-end equipment, right? Okay, so next point. Now we have completed the first part of the setting up a laboratory. Okay, so which means we know why we need a laboratory and what are the basic requirements. Now we are going to discuss this in detail. Okay, so yeah, let's start this. There are major components involved in a laboratory. What are the components? First component is obviously building and building facilities and construction. We have already discussed this building facilities and construction here. See, obviously infrastructure and facilities are important, which needed because let's say if I have a microbiome lab, then I have to take the necessary precautions, right? If I have a chemical lab, then I have to take the necessary precautions. So according to the lab which I have, I will build and I will make the infrastructures accordingly. So based on that factor, this is a really important component, building facilities and construction. And the second one is organizational structure. This is nothing but there will be a chief food analyst, and under the chief food analyst we have food analyst, and then junior food analyst, and then other technical staff and management staff. That is called as an organizational structure. And the selection of analysis, which we have just discussed, what are the analysis we are going to do, and purchase of equipment. Based on the list of analysis, we are going to do the purchase. For example, if you are going to do only microbiome, then you have to purchase the equipment which is related to the microbiome. And appointment and maintaining the qualified analyst. Yeah, that is a really important point. But not only that, we need analysts, technicians, skilled and unskilled labor also. We'll get to know why we need an unskilled labor, but so these are some important requirements. And finally, we need to establish some SOP, standard operating procedure. And finally, here is an important point. We need to get a QA system. So previously we have discussed that we need to make a QA system, right? So how we will make a QA system? Using the ISO 17025 2017. So based on this ISO, we will make a QA system, quality assurance system. Okay, so but important point is we need to get this QA system and we need to get the laboratory Nabl accreditation within 6 months of setting up the laboratory. Which means if you have set up the laboratory, then get the QA accreditation and get the Nabl accreditation within 6 months. This word is really important, within 6 months. Okay, and you can see there are like basically 7 points which is mentioned here. All the 7 points will based on only one factor. That factor and important factor is analytical work. What kind of analysis? The methods lab intended to conduct. Okay, so this method, this choice of method is a critical, because if you are setting up a chemical laboratory and you have built a facility which is similar, which is actually relates to microbiome, then there is no use, right? So this is a critical step, like what kind of analysis work you are going to do. Based on that specific analytical work, you will going to make a construction, selection of buildings, facilities, purchase of equipment and putting in the place of equipment. I have given you some example. For example, these are the national reference laboratories. Okay, I have taken few examples. In the first example, we can say CFTRA, Mysore, has specified in the area of nutritional information and labeling. Okay, second, expert inspection agency will only test for the GMO. Okay, and the next one is Banja Biotechnology Incubator will check for sweets and confectionery including honey. Then ICAR National Research Center for Grapes will check for pesticide residue and mycotoxin. So these are the specified requirement. Based on the requirement, we will do the construction, selection of building, facilities and purchase of equipment. Okay, got it? And finally, Center Institute of Fisheries Technology obviously will check for fish and fish products. So you can study all those NRLs which is mentioned in the PDF which is given by FSSI. You can refer it. So I have taken few examples just to relate to you, like why it is important to specify these words. Okay. So next one is, see, obviously the food analyst lab is ultimately checking an analytical process. Okay, which is used for regulatory compliance. What is a regulatory compliance? Which means we can use this for finally in case of any adulteration happens, or any other, like let's say intentional adulteration happens, then we can use this as a regulatory compliance. Okay, to give penalty or punishment. Okay, that's why this analytical process is used for regulatory compliance. Okay, now that means this analytical process is ultimately the foundation of lab, right? So if we are going to check for fish and fishery products, we can definitely sure that the products which is given to the Central Institute of Fisheries Technology will check the quality of fish and fish products. So the foundation of lab is based on the analytical process. How to attain this analytical process? Okay, we need to follow rigor and highest standard of regulatory compliance. Okay, and met the international requirement. I will give you an example. If let's say I wanted to check the caffeine of a coffee, which is given as a 300 mg as a standard, international standard, then what I will do, I will make the analysis and I will compare this with the international standard. If it aligns with the international standard, then we can say that this attains the highest standard. Okay, so the analytical process is done with the highest standard and we will follow higher rigor and higher standard of regulatory compliance. Okay, got it? Now we have learned in everything about the analytical process and everything. Now let's go to the perspective of a food analyst. Okay, so this is the flow chart will be followed irrespective of the size, location and infrastructure of a lab. So I have made the flow chart in a much simpler way. Okay, first of all, the receipt of sample for analysis. So let's assume a story now. Okay, a food safety officer, he has recently visited a food business operator and he has taken few samples. Okay, so now food safety officer come and gave the sample to the food analysis. Okay, it can be either given by food safety officer or DO or FBO. Okay, so with the request of analysis. Okay, now this receipt of sample for analysis is given. So who will receive it? It is received by the sample custodian. Okay, now he has received the sample. Then he will either store the sample, okay, and he will secure the sample. So what is the appropriate storage? Which means, for example, if the product is ice cream, then I have to given minus 18 degrees Celsius. Okay, so according to the product, we need to give the appropriate storage and security. Why we need a security? That is also important because we can say some forgery might happen. Some people might let's say tamper the product. So for that reason, we need to have a security. Then the next one is after receiving the sample by the custodian, he will document the sample. Based on the data given by FSO, he will document the sample. Okay, and he will open it and he will do the coding and other things. So we will see this point in detail how he will do it. Actually, he will do it under CCTV surveillance so that it will be recorded. So I'll explain this in deep later. So now this sample will be issued to the food analyst. Now this sample will be given to the food analyst. So once the food analyst receives the sample, he will prepare the sample. Okay, for example, if he has to grind the product, if he has to make powder of the product, so he will make the sample preparation. That is the next step. In case if the sample is damaged, he will request the DO for one more sample. That we already discussed in many classes. So it is simple. Okay, so after the food analyst has prepared the sample, he will perform the required analysis. Okay, he will perform the analysis. So once he has performed the analysis, he will document the data. Okay, he will document the data and that data will be verified. Okay, that data will be verified and approved by the authorized person. In this case of food analysis, we can say chief food analyst is a person, food analyst, or else we can say director of that laboratory. Director of the food laboratory, or we can say chief food analyst can verify and approve the sample. Now once he has done with all those report and verification, he will dispatch the sample to FSO, DO and food business operator. Yeah, so this is the flow chart of how the sample will be received and how it is processed and how it is dispatched. Okay, now here comes the important part. In order to achieve this word, like the regulatory compliance, right, which means it will be regulated. So there are key important 4 points you need to consider. That is accountability, who will be taken accountability for the product, and security, whether it is under security or not, then integrity and chain of custody. You ignore the chain of custody. I will explain this 3 points. Accountability, who is responsible, okay, and under whose security is this there, and integrity, we should not tamper the product. If all these things met, then it ensure the legal defensibility of an analytical data produced by the lab. Which means if in case the food business operator goes to court stating that the product has been tampered, I have already previously told you that all these things will be done under CCTV camera, right? And we know who is accountability, security, integrity and chain of custody. Then we can say as a defense, the food testing laboratory will say a defense that it will done under accountability, security, integrity and chain of custody of sample. Okay, so this is the defensibility of an analytical data produced by the lab. This is the very first point which is given in the syllabus. If you can open the syllabus and see, this is the first point given by the syllabus and you have completed the first point. Okay, now let's check the chain of custody. It is, we don't need to study this in detail, but I'll give you an example in order to understand the rest of the topics. So this chain of custody means responsibility for maintaining all the details should be clearly defined. Okay, which means who is responsible for the product, who is responsible for the sample. For example, let's take a chain of custody of sample. In the date 1/2023, FSO has submitted this to custodian. That means the chain of custody now transferred from FSO to custodian. Okay, now who has the chain of custody of sample? It is with custodian. So in the date of 1 to 3, it is with custodian. In the date of 3/1/2023, this will be transferred from the custodian to food analyst. Okay, so he will analyze the sample within 14 days. Once he has analyzed the sample within 1 month, this is a really important, after completion of analysis of sample in 1 month, or we can say 30 days, he has to discard the sample and destroy the sample. Okay, he has to discard the sample or destroy the sample. So that's why we can say that the sample should be stored in the lab for a fixed time. So from this graph we can see that who has the chain of custody of sample at what time. So if any tampering happened in between, we can point out who has the responsibility, who has the accountability, right? Okay, so let's check how to get the accreditation, Nabl accreditation. Okay, see, if a laboratory is there, it has to ensure the measurements result, for example the ultimate result, are traceable to the international system of units. Which means, see, if you have 300 mg as an international standard, so if you have a product value which is 100 mg, then you can trace it to the international standard, right? You can tracing it to the international standard, because you can compare this, because both the values are same, the standards are same. That is that word is called this the traceable. Okay, now let's see how to achieve this traceable. Okay, you can achieve this by follow two important persons. One is the Nabl. Nabl you already know, because they will do the calibration. Okay, once we have done the calibration, it will be aligned with the standard. And the second person is NMI. NMI means National Measurement Institute. So the CSIR of National Physics and Laboratory in New Delhi, okay, they got the NMI certificate. So see, we can follow the Nabl, but why we have to follow NMI, which this word I might have told you that Nabl is an important factor for accreditation. But why we need to go for the NMI? Because this NMI will give the certified values. Okay, certified values, which means, see, if the 300 mg is a certified value, then we can compare the standard, right? If the 300 mg is a certified value, which means this is considered as a standard. So if you have 150 mg or something, then you can compare this with the 300 mg. If it is less, then you can complain it. So the standard will be given by the certified values are provided by the NMI, National Measurement Institute. And basically the example of National Measurement Institute is CSIR of National Physics Lab, which is in the New Delhi. Okay, so why this NMA value, which is already explained, because the NMA is accredited actually. Okay, so this NMA is accredited for National Reference Material Producer. Reference material producer is nothing but, which I have told you previously, which is 300 mg. This reference material produced by the NMI, and this reference which is given by the NMI is a traceability to SI, which means which can be linked with the international system of units. That's why we are following the NMI. Okay, now I can clearly tell that NMI is also used because this can be accredited, okay, to give the reference material producer. Okay, so this reference material produced by NMI will be traceability to the SI, so we can use this data. That's it. So based on following these two principles, first one and second one, calibration provided by NABL and certified values provided by NMI, we can efficiently measure the results and trace to the international standard. Okay, so now let's move on to the next point, which is the laboratory organization. This is the second point which we have discussed. Organization. What is an organization? See, if you are taking a food testing laboratory, so the head is the head and chief food analyst. Under the chief and head food analyst, we can say we have an analytical staff, administrative staff and support staff. Under analytical staff, we have senior food analyst, junior food analyst and technical officers. See, under senior food analyst, I'll tell you the roles of each and every person. First of all, let's understand what is the analytical staff. Analytical staff means these are the person who will do the analysis. Okay, these are the persons who do the analysis. And administrative staff means these are the persons who determine the price and who will make the administration run smooth. And finally, support staff. These are some staff which helps. For example, we can say support staff like, for example, cleaner as a support staff and all those persons. For even we can say custodian as a support staff. Okay, so let's get into the role of each and every persons. So the first one is senior food analyst. The senior food analyst is ensure the weekly deadlines of test results. He will be given the weekly deadlines of test results, and he is the one who's ensuring that. He is not checking anything, but he has to ensure with the junior food analyst. So that is the first point. Second point is he has to do the QC. So here who will do the QC? Quality control. The senior food analyst will do the quality control. And we have also seen that we have to develop an SOP. So in this case, senior food analyst will do the SOP. Okay, so these are the roles of senior food analyst. Now following the SOP is the role of junior food analyst. Okay, and he has to do the other analytical work also. So he has to follow the SOP and he has to do the other analytical work. Okay, so yeah, so basically these are some important roles of junior food analyst. So we are studying for junior food analyst, so you know what is an SOP and what is an analytical work. And third person is technical officer. Technical officer can also do the analysis of chemical, microbial and maintaining the log of the analysis. And he will book the log, document it and maintain the data. Okay, and he will be assisted by the technical assistant. Okay, who can do the sampling, grinding, sieving, mixing and autoclave. I have told you, right, he is an unskilled staff. Unskilled. He is an unskilled because there is nothing much skill involved here, but these roles will be done by the technical assistant. Okay, now here comes an important part. We have an optional QC section. See, usually the QC will be done by the food analyst, but in order to get a guaranteed, accurate, reliable and analytical results, we can have an optional QC section. So how this will guarantee it? This will randomly take a QC sample. For example, if 10 samples is given today, he will take any one sample and check the reliability of the lab results, whether it is comparable to the previous results or not. So that is the role of QC. Okay, so now here comes the map of the one which I have discussed earlier. We can see head and chief food analyst is there. Then these are the administrative staff, and these are the support staff, and these are the analysts. So from here to here we have some analytical staffs are there. Yeah, so let's move on to the next one. See, I have already shown you this whole table and flowchart, right? You can go through this, and under each senior analyst we have a junior analyst. We have one or two junior analysts, and under the junior analyst we have technical assistant. But let's assume a food laboratory. Okay, we need to analyze minimum 100 sample per month. If you are building a food laboratory and we need to analyze minimum 100 sample per month, these are the requirement of manpower. Okay, so let's see the manpower. We need one director, one joint director, and 4 assistant director, and 2 analysts with essential one having a background in microbiology because he has to do the microbial analysis, and 10 technical officer, at least 2 having the background in the microbiology because he has to do the work. So as we have discussed here, under each analyst we have 2 junior analysts, right? So that data. And here the important part is, see, overall 41 members are there. Okay, that is not the important part. Important part is 27 people are essential, which means they are must. 14 are desirable. If you want to have, you can have it. Okay, so the must people are 27 and 14 are the desirable. This is to achieve checking of minimum 100,000 sample a month. Okay, this is a manpower required for that purpose. Okay, now laboratory buildings requirements and designs. Okay, let's check the general requirements. If you talk about a building, what is a general requirement in general? Okay, good infrastructure is there. I mean that it should have a good road system, which means it will be easily accessible, right? Power supply and portable water. So even if you take your home, these are some of the general requirements, right? Second one is there should be a separate building to use chemicals and hazardous compounds. This is in case of laboratory. You should listen to this point carefully. We should have a separate building for chemical and hazardous compound. And third point, safety. There should be a safety and healthy environment. Adequate lighting should be there. Ventilation and safety systems and so on will be mentioned. So these 3 points will ultimately the general requirements for any designing of the laboratory building. Okay, now let's discuss the layout. Sorry. So the layout which is been planned will be based on the analysis to be carried. This we have already discussed so many times. Why? Because of no cross contamination. I have already discussed that also. We cannot put microbial lab and gravimetric lab nearby because it can cross contaminate, right? And future analytical requirement plus expansions, which means if suppose you have a laboratory and you have an empty space, you have to leave the empty space in order to expand in future, right? So future analytical requirement and expansion, and separate section based on the type of analysis. I have just discussed laboratory, microbial laboratory and gravimetry will be separate with each other. So first we need to see 3 important parts. Sorry, one second. Okay, so first one is sample receipt and registration, and the second one is sample storage room, and the third one is primary processing and subsampling. So these 3 labs are really important. Okay, so what is this 3 important parts of a laboratory? Because see, in this first one we will receive the sample, and then in the second one we will store the sample, and the third one we will process the sample. Till the 1, 2, 3 there is no analysis happening. So analysis will happen in the next section. So what is the primary processing and subsampling means? Which means we will be grinding, sieving, and see, that's why it is separated from this laboratory, because this will create the dust and noise, right? This will create the dust and noise. Okay, so what is a gravimetry? So in case some people might ask, so I have mentioned here, it is to check the weight, drying and incineration. So to do the role of weighing, drying and incineration, we need a general gravimetry lab. Okay, now let's discuss the points to remember before building a laboratory. Wet chemistry lab. Wet chemistry lab is nothing but this is a lab for extraction, filtration and all those things. I will discuss the wet chemistry lab in detail, but now remember, wet chemistry lab should be separated from microbiology lab. Because of what? Obviously it is a wet chemistry lab, so it will contaminate, and here also sample preparation lab, so contamination and mycotoxins will be there. So that's why wet chemistry labs should be separated from sample preparation and microbiology lab. And next, second one, atomic absorption spectroscopy, flame atomic absorption spectroscopy. In this case, if you have a flammable substance and if you have a flammable solvent along with corrosive chemical, it will become a hazard. So in case of atomic absorption spectroscopy, you cannot put corrosive chemical near the mixing flammable solvent. Why? Because it will create a hazard, and which is prevented by cleaning prior to analysis. Okay, so we should clean each and every time when you do an analysis. You have to clean the specific instrument which you are doing. For in case this case is atomic absorption spectroscopy. And in case of HPLC and GC, if the room has major dust, then it will not be working properly. So the room should be dust free. Okay, and we should control the humidity and temperature, because gas chromatography, if the room has dust, then it will interfere with the result. Same with HPLC also. And in case of aflatoxin analysis, the room should be small dark room. Okay, and in case of mycotoxin analysis, it requires a biologically safety cabinet, which means it will not contaminate once you put the specific product in the cabin. Like for example, if you are checking mycotoxins, let's say mycotoxins of apple, let's say you want to check the mycotoxin in an apple, we know it is contaminated with some mycotoxins. We need to check how much it is. So before using this, we should keep it in the proper place so that it will not spread to the other people. So that is called as a biological safety cabinet. Only if you want to do the mycotoxin analysis, you need the biological safety cabinet. Rest of the things you don't need it. If you are just going to do the proximate analysis, why we need a biological safety cabinet? So that is the first one. Okay, now let's discuss the first three rooms in detail. First room is sample receipt and registration. This is an entrance of a laboratory. Okay, FSO will request for analysis, right? Once he has request for analysis, this request will be logged in the sample register. Either it will be logged manually, which means the custodian will enter himself, or this will be mentioned in the LIMS, Laboratory Information Management System. Okay, so these two, using these two factors, we can log the sample register. Now the sample parcel is opened under the CCTV surveillance, so that it will be recorded in case of any let's say fraudulent or any mischief. Okay, now all the informations starting from number of seals and packaging materials and condition will be recorded. Okay, will be recorded, and CCTV surveillance is also there. Okay, now see, there are two things. One, this sample, after the custodian recorded it, he can store under appropriate condition, or else it will be forwarded to sample processing and subsample processing. Okay, so this is the first room, which is sample receipt and registration room. So this room has specific function. First one is the area should be 50 square meters, with a large window and access control for authorized person only, obviously, because we can tamper the info of related to number of seals, packaging materials and condition. So the area should be really properly mentioned, and we should have an access control for authorized person, and obviously we should have a LAN and CCTV, and we should also have some refrigerator to keep the samples, as we have told, and freezer. Okay, so like secured sample storage facilities. And finally, for safety, we need a fire extinguisher, hand wash facility, first aid kit, and segregated waste disposal system. In case if the package is tampered and if it contains some kind of, let's say, a dangerous substance or something, we need a proper disposal system in the receipt area itself. Yeah, now we have completed the first room. Let's move on to the second room, which is sample storage room. Okay, so 3 important points basically. So first is, you should not alter the sample condition. The storage room should not alter the sample condition, which means it should not do any contamination. The room, it should not cause any loss of the sample and deterioration of the sample, and all these should be prevented. Okay, all these things should be prevented. How to do this? It's simple. To maintain a proper temperature and humidity. If we have a proper temperature and humidity which is needed for the specific sample, we can keep it, right? And CCTV surveillance is also there. And finally, physical security. Physical security means obviously only the authorized person can enter, and it will prevent the intention adulteration and alteration, which I have told you previously. If someone else has a key to the room, he will come and make the tamper, or he will do the intention adulteration and alteration, which will ultimately lead the sample to be adulterated. So that's why this is an important room, and it will only allow the secured persons to enter. So all the other things are same, exactly same, except one point, which is the humidity and temperature. Here the temperature is 20 plus or minus 2, and the relative humidity is 50 to 70. All the other points are same. Okay, and here one more important point, which is shelf and cupboard and alamari is there. Okay, basically that's it. Now the third room, primary sample processing and subsample processing. Okay, so why we need a primary sample processing or subsample processing? Why? To attain the homogeneity. We can grind it depending on the size, so all the products will be in the same size. Okay, and see, obviously this is not needed for flour and liquid because it is already in the same size. Okay, it is already in the same size. Then what we can do for that? For flour we can do just mixing, and for liquid we can do just shaking. This will attain the homogeneity. Yeah. Okay, so in this room, primary processing and subsampling, we will do the subsampling, which means dividing and then blending and then grinding and then pre-drying. So all this process will be done in the primary sampling, and this is the sample process, and this is ultimately called a sample process and preparation. Okay, and guys, as I have told you previously, this will create a lot of dust and noise. Okay, this will create a lot of dust and noise, so we need to remove the odor and heat regularly. Okay, we need to remove the odor and heat regularly. Next one is, there is the safety kit we need to wear. Safety kit. So the first one is mask, obviously, because it has dust, and earplugs, which means it is to avoid the noise from the grinding, and muff. So these are some of the important points. These are compulsory, guys. It is not like we have to wear it or something. It is compulsory. Okay, so you have to wear this. So what is the requirement? So the first one is area. It is 50 square meter. Okay, it is 50 square meters. Obviously we have land, CCTV surveillance, and if we are doing the grinding and blending, we should have a grinding mill and blender. And if any dust is there, then we should have a cleaning sieves and grinder. And there are some ventilation system also for grinding. In order, we have told you that we have to remove the odor, right? So that one. And sample splitter, drying oven, top pan balance, secured sample storage facilities, and same refrigerator is 8 to 10, and upright freezer is 25 and minus 20. Yeah, so and all the other things are same. Here eye wash is mentioned because of dust, right? Eye wash is mentioned. Yeah, so that's it. Let's move on to the next laboratory, which is wet chemistry laboratory. Now I will discuss what is a wet chemistry. See, digestion, filtration, distillation, titration, extraction, derivation, dilution, all these unit operations need a liquid or water to do the process. That is called as wet chemistry laboratory. Okay, there are few conditions for this lab. The first condition is independent laboratory rooms for the independent activities, because it will alter the product, right? So independent laboratory rooms for independent activities. And if you are using some acid, or if you are storing the acid in case of titration or dilution or something, then you should have a separate area. In case if you are doing the distillation, then you need some flammable solvent, right? So you need to have a separate area. Okay, and the laboratory space for each and every room which is mentioned here will be 10 square meters. Okay, and the bench surface will be 3 meters for each analyst. If the analyst is sitting and if he has a bench or something, then each analyst should have at least 3 meter distance between each other. Okay, then here are some of the important laboratory. First one is proximate and general analysis laboratory, and the second one is nutritional evaluation, and the third one is wet laboratory, which means pesticide residue and mycotoxin, and the fourth one is instrumentation room and heavy metal analysis room, and finally sixth room is glassware and washing and drying room. Glassware storage, actually it's glassware storage, washing and drying room. Let's discuss these rooms in detail. Okay, first of all, we have proximate and general analysis room. Area is 60 square meter, and we need few equipments for proximate and general analysis. We need a muffle furnace, titration, refrigerator and hot air ovens, and then freezer, and many other important equipments which we needed to do the general and proximate analysis. And we need some furniture and safety equipments too. So that's it. This is the first room, and in the second room it is nutritional evaluation. So this nutritional evaluation room has same area, which is 60 square meter, and the equipments are much more higher, because there are many important factors under the nutrition evaluation, which is ultimately called as proximate room, right? Proximate analysis. So we need a weighing balance, titrations, filtration units, pH meter, oxalate fat extractor. So guys, see, you should know the detailed explanations of what is a oxalate fat extractor and what is a solvent used there, and what is a reagent used there. Okay, you need to know all these details in deep. So do study it in some books or materials, because that is an important point in case of food analysis examination. So next is automated protein digester and titration for Kjeldahl, nitrogen, reflex acid concentrator, rotatory evaporator, fiber and fat analyzer, centrifuge, okay, incubator shakers, hot air ovens. Temperature is mentioned 110 to 130 degrees Celsius for hot air oven, okay, and refrigerator, water purification system, vortex mixture, and then ultrasonic bath, water bath and hot plate freezer, and fume hoods connected to exhaust system. Okay, so we can remove the heat, water supply, gas supply, vacuum facilities, network connection or computer. And one important part is segregated waste disposal. Here they have mentioned for broken glass, chemical waste, plastic waste paper, computer waste and batteries. Okay, and chemical spill kits. In case of any chemicals has been spilled, how to remove that. And eye wash should be mentioned here. I'm repeatedly mentioning the eye wash because eye wash is really important. I will discuss that eye wash in detail later on. Okay, and then third room is only have 40 square meter. So what is the room 3? Room 3 is wet lab. Okay, so it has 40 square meter, and the equipments which we are using under this is obviously weighing bar and solvent filtration with pH meter, nitrogen evaporator, rotatory evaporator. This will be like obviously repeating each other, right? So that ones, and furnitures will be there, and safety equipments and protections will be there, and all the points are same actually, basically. Then instrumentation room. This room is much more different from all other room, and we will see the room in detail later on. I will show you the outline of the room so that you can understand it much better. So let's discuss some important points here. So first point is the room size. It is the biggest room out of all, 100 to 120 square meter. Okay, and the temperature is not 20 plus or minus 2, it is 20 plus or minus 3 here, not 2, 3, and the humidity is same, 50 to 70. Late humidity is same, 50 to 70. Okay, what are the equipments which is had? Gas chromatography with FID, HPLC with RA, fluorescence and photodiode array, UPLC, tintometer, Fischer titration, UV visible spectrometer, elemental analysis, microscope, then fluorescence spectrometer, and then nitrogen and hydrogen generator, gas purifying panels and system, uninterrupted power supply, water and gas supply, air conditioner, and a thermohydrometer, purified water system, network connections obviously. So, and furniture will be vibration free, because obviously instrumentation lab with like it might vibrate, so we should have a table which is vibration free. Okay, and these are some this laboratory safety and equipment is similar. Okay, so nothing we need to worry. And heavy metal analysis, see guys, there are two different areas. Okay, so sample preparation room is 15 square meter, and the area for handling the AAS or ICP-MS is 30 square meter. Okay, it is 30 square meter, and the very first important points mentioned in the room and environmental requirement is dust free. So that's why I have like told you 3 to 4 times, dust free is the important point. Okay, dust free, and controlled temperature 20 plus or minus 3. Okay, the same as previous one. And short term variations must be at a maximum rate of change in 3 degrees Celsius per hour advisable to have. Like basically, if the temperature is changing, then we should only change 3 degrees Celsius per hour. Okay, and late humidity is 20 to 80. It is not 50 to 70, guys. Here is 20 to 80. Okay, and we have a hygrometer and temperature to check the temperature and the humidity, and sturdy table will be there. So in case if you want to circulate freely, then all other important points will be there. Like I'll tell you the important points only. So the flow rate of venting system should be 700 to 8500 liter per minute. Okay, and air circulation should be provided, and graphite furnace should be provided, uninterrupted power supply, and water and gas supply. And the equipments is basically simple. We need AAS, then microwave digester, and clean bench for AAS sample, because it can affect the quality of sample if the bench is not clean. Okay, flow mode in the sample preparation room, and then refrigerator, freezer, and analytical balance. Then power supply. See guys, obviously this is a room which requires a lot of power supply because of AAS. So here the power supply must be higher, right? It should have some fluctuations in the power supply. So the main voltage fluctuation should not exceed plus or minus 10. So this point is really important. It might ask in the examination, because the major factor of building a laboratory is the power supply. If the power supply is not properly provided, then the laboratory cannot run. So in this case, all other laboratory doesn't mention this point, but in this case of AAS, plus or minus 10 should be there. Okay, and measured ground to neutral potential, this is not much needed, but the fluctuation should be not greater or plus or minus 10. And power supply board with sockets must be located within 2 meters, and it's recommended that time delay fuses and circuit breakers are used to prevent the nuisance tripping. See, I told you just now, it will trip. Obviously the trip will be happen much more often, so we should have a fuses and circuit breakers in order if in case it happens or something. Okay, so next one is additional protection to be provided for instrument means of ground fault circuit interrupts. Yeah. Then gas requirements. So yeah, what is the requirement of gas? I have told you before, it should be dust free, but what is the requirement? So the requirement for the frame operation is 28 to 30 liter per minute, and the pressure is 350 kilopascal. Okay, and we should use acetylene for major of the analysis. Okay, and the air acetylene is a preferred flame for the determination of 35 elements by the atomic absorption. Okay, so you can study that in deeply. And nitrous oxide is 99% minimum purity is there. Okay, so for if you want to use a nitrous oxide as a gas, Okay, if you want to use nitrous oxide as a gas for flame, then dual stage regulator is mandatory, because if you don't have the dual stage regulator, then it might explode. So you should be aware of the dual state regulator. Then argon, if you want to use that, then it has the highest purity, 99.96. then it should be dry in order to attain it, and two stage high purity gas regulator should be there, obviously. Then all other points, like all other safety equipment should be mentioned here. Okay, then finally room 6. The room 6 is the glassware washing and drying area. This room should be separated out of all, because this room is one of the important room, because this room should not be contaminated at all. Then if it is contaminated, then all the other analysis which is done using this glassware will be faulty. Okay, so the area is 30 square centimeter, 30 square meter, sorry, and equipment is hot air oven, drying cabinets, and automatic glassware washer. Hot air oven is 110, and drying cabinets to dry the glassware is 50 to 60. Okay, so the furniture and related items. So obviously, yeah, we have water supply, rodent free drainage system. Okay, because this is the area for washing, we might export that rodents and other things and all. And all other safety equipments and all other things are same. Now we have discussed almost every lab except one lab, which is microbiology lab. See, in case of microbiology, we should have a separate cabinet for support equipments and biological equipments. What is a support equipment? Support equipment means autoclave, laminar airflow, biosafety cabinet, and glassware. Biological equipment means indicators, reference materials, and media, which will used for the biological experiments. Okay, we should have a separate equipments like this, and the ventilation should be separate. For example, if the instrumentation room plus microbial room have same ventilation, then it can cross contaminate, right? So for that reason, ventilation should be separate, and the quality of air is mentioned in the ISO specification. Okay, and it can prevent the cross contamination, just like I have told you before. And restroom, guys, this restroom will be separate from the microbial lab. See, the I will show you the outline later on. The microbial lab should be kept as far as the restroom. Why? Because of cross contamination. There should be a definite cross contamination might happen if it is kept near. So it should be separated from the restroom, and it will prevent the cross contamination. Okay, the people should follow what are the important things the people should follow in order to enter a microbial lab. First is appropriate entry and exit procedures, including gowning. This is the process of gowning. As you can see here, we are wearing a gown in order to protect ourselves from the major accidents. And the next one is intended use of clean rooms and corridors. And restricted imposters, whoever is restricted from entering the place should be restricted. Only the authorized person should enter. And we should have a contaminated bio level safety. BLS2 for closed reading botulinum. I will explain you what is this BSL2. Okay, what is this BSL2? Biosafety level 2. This is called as biosafety level 2. I will explain this BLS2 in detail later on, but we should have minimum this safety level. Okay, I will explain this. And finally, back fastening laboratory gowns or goes. Example like this, we should immediately put it, and we can immediately fasten this laboratory coat, and we can go. Now let's discuss this outline of laboratory in detail. So the first laboratory, the A, which you have seen here, that is the lab for the 8 analysis. So fume hosted, digesters, oxalate extraction, sink, freezer. So in this specific room which they have mentioned, we can do at least 8 analysis. And in this room we can see the each food analyst have provided 1.5. which means food analysts have the working table and the separation between them is 1.5 basically. Okay, so this is the lab for 8 analysis. And now let's come to the second laboratory. This second laboratory is the instrumentation laboratory. Instrumentation laboratory. Okay, so I have told you before, I'll show you the instrumentation laboratory. So here let's see this instrumentation laboratory. Bench for small equipment optional. Okay, so bench for small equipments. Then we have a equipment like GCMS, GCFID, UV, ELISA and other readers. Okay, and the distance is 1 meter. Then we have a gas lines going in between them, and we have a equipment of spectrophlorometers and the UPLC, and finally bench for small equipments. So as we can see here, we have different set of equipments with distance of 1.5 meters. Okay, so if you have a 1.5 meter distance with each other, then that is enough. Then we have a sink at the end. Okay, yeah, so that's it. So this is how we need to build an instrumentation laboratory. So this is the outline of all the laboratory. So okay, so let's see this. See, let's start with the instrumentation laboratory here. See, instrumentation laboratory will be kept separated from the microbial laboratory here, and will be kept separated from the pesticide laboratory. Okay, so above the instrumentation laboratory we have a UPS room, then side is gravimetry and proximate and gravimetry room, and nutrition evaluation room. This room is been like it is not that much of separation is there, so we can see we can come here. Why? Once we have checked the weighing or drying, we can immediately come here and check the nutrition evaluation. Okay, microbial balance, pH meters will be mentioned here. Security and reception will be here. So any person who is coming here will be come from this. Okay, and lockers for analyst, like sample and recording and reporting will be there, and sampling and storage that I have told you, like room 2 and room 3 will be mentioned here. Okay, and as I told you, see, restroom is here, and where is the microbiology lab? It is way under this, because we need to keep separate to cross contaminate, in order to avoid cross contaminate. Yeah, okay, so that's it. So this is the outline of microbiology lab. See, in this outline we can say decontamination, incubation and enumeration. See, we can understand all these things, but there are few words which is mentioned here which is really different, which is class B. Okay, class B. What is a class B? And what is a dynamic boss box and what is a static boss box? So these two important, boss box and the class A, class B, I will discuss this now. So basically from this layout, if you want to take a screenshot of this layout, you can take it. Then if you want to study this, you can study this. Once you have studied this, then let's go on to the next point. See, from the layout which you have seen above, you can see 3 to 4 things. First is pressure difference. The pressure difference will be different in individual laboratory, right? So what happens is safeguarding the pressure difference between the lab and lobby. So if you are entering one room to other room, the pressure in the room will differ. It will change many factors, temperature, changing the pressure and changing the gas constant and many other things. So safeguarding the pressure is a major important factor. So that is the first point. And the second point is class B, class D. What is this class B, class D? It is called as installation guide. Okay, class B means we assume that room has less than 200 CFU per meter square, colony forming unit per meter square. And class D means this room has less than 50 CFU per meter square, which means the class B room is much more contaminated than the class D. But this levels which is given here is a safety level. So we will design the room in order to ensure the safetyness. For example, class D, we should not put much effort into the safety because here is only less than 50 CFU, but in case of class B it is 200. So based on the class, we will prepare the room and we will have the safety equipments according to the class. Okay, class A, class B and class D. Okay, and see, some classes are even undefined, unclassified. For example, in the sample receipt room, obviously we cannot calculate how much of it's a CFU will be there, right? For that case, we can just simply put unclassified, because we cannot determine it until unless we check it. So that's why that room is unclassified. Then the third one is wash basin. Wash basin will be only located near the exit. This is exactly same as what I have told you about restroom. So because it can cross contaminate. And finally, waste disposal, which will be provided at the appropriate place. Okay, so in case each and every room has a waste disposable system, and according to the waste we have to dispose it. Okay, so we should not move like so frequently with this. And the one more important point, which is the pass box, right? What is a pass box? Dynamic and static. I'll explain that now. See, equipments of microbial lab. There are two equipments. One is a dedicated equipment which should not be moved, and the samples. Samples should be moved, but it should be moved with the pass boxes. Pass boxes is kind of like a box. In that box, you will keep the sample. So the sample, if it is contaminated, it will not spread to the other people. Okay, so if it is a dynamic pass box, then it can be moved easily. If it is a static pass box, then once it enter into the room, it cannot be moved. Okay, once it enter into specific room, it should not be moved. That is a dynamic and static pass box. Okay, so using the pass box, we will let's say transfer the samples from one place to another place. Now these are some general, like we have discussed all the rooms, as you can see. Now the rooms are over. Now let's see how to utilize the space. First is accept the support spaces. So like for example, let's take here. Here we can see these are some support places. If you want to go from one location to other location, you can use the support spaces. Okay, so that is the first point. Access the support spaces required. And administrative office. See, if you have a laboratory and if you keeping the administration office inside, then many people will come and go into the administration office. Like, and not only the people of FSO, DO and other people, even like general public and many people will come to the administration office. So this administration office will not be kept inside the lab. It is not kept inside the lab. Okay, it is not kept inside the lab. Rather, it will be a close proximity to the lab. For example, if let's say this is a lab, then inside this we have a receipt room, but we don't have an administration office. Administration office will be kept here in a separate building. Okay, so the people who has only the role of administration, they will come here and do the work and go. And the people who has to do the sample analysis, they will come to the actual laboratory and they will give the sample receipt and do all the work. So that is a role of administration office, and it should be in a close proximity. For example, if this administration office is related to this lab, then it should be in a close proximity, right? Yeah. So, and the third one is documentation area should be kept inside. Okay, so see, administration office, we told you close proximity, but documentation area should be kept inside, and but not near to the hazard and chemical storage places, because we cannot simply set each and every place to write the documentation. That should be a separate area to write it, and this area should not near any hazard or chemical storage place. Okay, finally, security. What are the security things we needed? We needed security like restriction to access. Every person cannot enter into every room, so there should be an access to individual people. For example, only microbial food analyst will be entered into microbial lab. Only custodian will enter into the storage room. So that is a security, and it has CCTV installed in every places. Obviously, we have told you, and should be fireproof. Okay, the fireproof is an important word. Okay, so because each and every industry, each and every lab which we have seen might have some drawbacks, and it might like build a fire or something. So we should have a proper fireproof around each and every laboratory. And finally, sink. Sink means, see, three important basic facilities in the sink. First is hand washing facilities, and we should mention the types of hand washes. Okay, and steps of hand washes, that should be mentioned. And we should follow biosafety level 2, which is recommendable. This biosafety level 2 is the BSL2. which I have told you before. So, and it should be stainless steel, made in the stainless steel. So what is this BLS2? Design requirements for BLS2 laboratories include hand washing sinks, eye washing, and in case of accident, doors are automatically closed and locked. So this is the room of BLS2. So if you want to make the BLS2 biosafety level 2, then you should have a room of hand washing, sinks, eye washing, and in case of any accident, and door should automatically close and lock. This is the biosafety level 2. Okay, in case something happens. So what is the other biosafety levels? There is 4 biosafety levels: 1, 2, 3, and 4. In case of 1, there should be no contamination, so you don't need to close it like something like that. Okay, and it is unlikely to cause disease, for example E. coli. In case of HIV, Lyme disease, influenza and all, it is a moderate risk. So basically we need to prepare for the BLS2. BLS3 is highly contaminated. Okay, it causes tuberculosis, and BLS4 is a maximum contamination, which means it is a life-threatening disease, for example Ebola virus. Okay, and we have to follow the BLS2, which means we should assume the disease will be related to this one, so we should have a proper safety measures which is related to the BLS2. Then laboratory signatures. Laboratory signatures means we should understand based on the like stickers which is mentioned here. Okay, so the first signatures is the protective clothing. If a laboratory has mentioned this specific signatures, then you should ensure that you are wearing the specific one. First is the personal protection. Let's see what are the mandatory requirements. Protective clothing, hearing protection, eye protection, we can see eye protection, and hand protection and hand wash. Okay, then respiratory protection. See, it is not equal to the see, this respiratory protection, it's not similar to eye protection or ear protection or something. It not means mask also. It means respiratory protection means we should wear this kind of equipments which help you to respire apart from the air inside. And food protection, and finally face and eye protection. Okay, so next is safety equipments. Emergency eye wash in case something happens. Then emergency safety shower, same. First aid, and then emergency assembly and location assembly point. For example, if any fire incident happen, we should have an assembly point to all the people to gather there and escape there. And then emergency exit. Then fire extinguisher, fire blanket, and fire hose. Okay, in case fire happened. Then recycling symbol. So this should be mentioned in the dustbin, and only the plastic which has to be recycled should be mentioned, which should be put inside the recycle bin. Then prohibition signs. These are the prohibition signs. First is prohibition symbol. So this symbol means it is prohibited. Okay, and then unauthorized person only. So that is the symbol. And no smoking, no open-toed shoes, and no food and drink are allowed. Okay, and no open flames, no dumping chemical, and no potable water. Do not touch. No pacemaker. Okay, so if you have a pacemaker, then you should not enter into the specific room because it has some vibrations which affect the pacemaker. Do not eat or drink. Do not enter. Okay, so these are some important signatures. And hazard and danger signatures. Unstable explosives, flammable, oxidizing, compressed air, and corrosive health hazard. And systematic hazard, toxic and acute toxicity, harmful, which means, see, this symbol is harmful, this symbol is toxic, this symbol is systematic health hazard. All the symbol looks similar, but it has a different meaning. And environment hazard, and finally radiation symbol. Okay, then warning sign, biological hazard and laser hazard, radioactive, high voltage. See, this might look similar, but this is a radiation symbol. This is a radioactive radiation. Okay, so then this is hot surface, extreme cold, non-ionizing, strong magnetic and optical radiation, and chemical weapon. Okay, now let's discuss the waste disposable. Whose responsibility to dispose the waste? Head food analyst and all other food analysts. Okay, under the head food analyst, all the analytical staff will be responsible to dispose of waste. So the waste can be categorized into 3 different categories based on the identity, based on the constituents, and based on the hazard. and we can read the book Ulrich Handbook, which is, see, this book is not mentioned by me, this is mentioned by the FSSA itself. FSSA has recommended this Ulrich Handbook, which has a summary of correct disposable procedure. So based on the book, we can use it to remove the disposable systems. So waste can be divided into chemical waste and biological waste. Let's start with the chemical waste. Chemical waste means solvent, aqueous solutions, dry powder, unwanted old chemical. Okay, so see, this chemical waste can be removed by many methods. So let's discuss a simple and easy method first. Washing down the drains of excess water. This means simply washing in the tap water. Washing in tap water. See, if you are a chemical student or biochemical student, then you might have done this many times. So once you have done with the experiment, you will wash it. But in certain cases, they won't allow you to wash in the drains, right? So in what case they will allow you to wash in the drains and what chemicals they won't allow you? I'll discuss this in detail. First of all, concentrated acid after dilution and dilute acids are allowed to wash. Not concentrated, dilute acids and alkalis. Okay, and harness soluble inorganic salts. This is soluble, guys. This is soluble. Okay, if it is soluble like CaCl2, MgSO4 and Na2SO4 or P2O5, then you can wash it. Alcohols containing salts, you can wash it. Hypochlorite solutions, you can wash it, like cyanates and phosphates, restaurant cyanates and phosphates. And TLSC grade silica and alumina, you can wash it. There are chemicals you should not wash it, and that chemicals are called as red list chemicals. So what is this red list chemicals? Okay, substance that do not mix or dissolve easily. Example, fat. They are red list because you cannot wash it because it will not mix properly, it will not dissolve properly. And you cannot mix the following elements: antimony, arsenic, barium, beryllium, boron, cadmium, etc. Guys, lead, mercury, zinc is also coming into this chapter. Even cobalt and copper. Many important chemicals has been mentioned as a like red list chemicals, so that red list compound, so that you cannot wash it in the drains. Next is halogenated organic solvent and organochloric compounds. Example, chloroform, dichloromethane, epichlorohydrin, then carbon tetrachloride. These chemicals, halogenated organic solvents, should not be washed in the drains. Then toxic organic solvents like methanol, acetonitrile, xylene should not be washed. Organohalogen should not be washed. Cyanates and azides should not be washed. See guys, cyanide waste must be placed in an appropriate waste bottle. It will be placed in the appropriate waste bottle, and the solutions kept the alkaline at all the times. Okay, so see guys, basically you should not even throw, you should kept in a separate box, and that box has been disposed later on. And antibiotics and formaldehyde and paraformaldehyde solutions, phenol, benzol and derivatives, mineral oils and hydrocarbon, poisonous organosilicon compounds and metal phosphates and phosphorus elements, and fluorides and nitrates. Okay, now the third method is, you should collect the solvent in a labeled containers and you should remove that eventually. Okay, so example is halogenated solvents. We have previously seen, you should collect the sample and in a labeled containers. And non-halogenated solvents, same, you should collect it in a labeled containers. And soluble organic waste, including most organic solids. Okay, see, soluble non-organic, sorry, so soluble inorganic, okay, soluble inorganic will be washed down in the drains. But in case of soluble organic, you should be you should be mentioned in the labeled container. You should kept in the labeled containers. And paraffin and mineral oil should be kept in the labeled containers. And now waste bins. Waste bins is the most proper and like most used method out of all in order to dispose, right? So it is color coded. First of all, we should know it is color coded. And second is, if it is 3/4 full, which means if it is 75% full, then you should transfer the contents into the larger container. Okay, so what are the different types of waste bin? So that are controlled waste, which means dirty paper, plastic, rubber, wood and all those things. And glass means obviously the glass which is broken, test tubes and bottles. And bottles means empty reagent bottles. See guys, this and this are different because this is used reagent bottles. Okay, Tops and caps must be removed from the bottles, put out for the disposable, and there should be no detachable smell of chemicals from any bottle put for disposable. So you should wash it clearly and dispose it. Metal sharps. Any sharp objects like can tops, pins, see, you should take this can tops and put it in the metal sharps. Okay. And plasticware. All disposable plasticware, including effin rope, wells and syringes and pipette and tips and plastics, you should be kept here. Batteries and waste for special disposable collected in the labeled individual boxes. We have already told you cyanide. Now mercury is added in the list. And the one more important thing, special waste. Okay, so in case of some special waste is there, you have to put it in the separate box, and this waste should be collected by the State Pollution Control Board, and it should be disposed according to the State Pollution Control Board. Now let's come to the biological waste. Biological waste means, first of all, you cannot dispose this waste. Okay, laboratory cannot dispose biological waste. Then how we will dispose? First, we should have a contract with a commercial film to dispose the biological waste. This commercial film should have license under the State Pollution Control Board. Okay, so they will come and transport the biological waste to a designated disposable site for the incineration. Okay, we should not do it. Only a certified commercial firm or firm can do it. Okay. Now the third part, which is accreditation. We have done almost all the part. We have done GLP. I have included the GLP with the with the laboratory setting up. So you have studied the first point and third point. The only thing which is left is the second point. Now let's study the second point, which is the accreditation. So accreditation is a third party attestation which is related to conformity assessment, body conveying formal demonstration of competence, impartiality and consistent operation in performing the specific conformity and assessment activities. I know this is difficult, but let's divide this into a simple point. Who is a third party? Who is a third party? NABL is a third party. Okay, NABL attestation, which means accreditation means NABL is giving some certificate. Okay, and what is a competence? Okay, to confirm the assessment body conveying the formal demonstration of its competence. What is a competence? Ability to apply the knowledge and skills to achieve the intended results. For example, if the lab has an ability to check the proximate test, then he has a competence to check the proximate test, right? So that is a competence. He has some knowledge and skills to achieve the results of let's say proximate test. That is the competence. Then impartiality, obviously we have to be impartial with one another, and consistent operation. Yeah, the results should not be changed every time, it should be consistent. Okay, in performing specific conformity assessment activities. What is a specific conformity assessment activities? Which is nothing but, for example, if you are doing ultrasonic testing, which is a specific conformity. If you are doing tensile testing, which is a specific conformity. If you are doing a specific task, then you should be consistent with the operation. You should be competent with it. You should be consistent with it. If you are competence, impartiality and consistent with the specific conformity and assessment activities, they will give a attestation, which is a certification. Let's say it is a simple word. Okay, who will give the certification? Third party. Who is the third party here? NABL. And who is the organization which is requesting this accreditation? It is a testing laboratory. Okay, laboratory, food testing laboratory. So that is the accreditation in simple words. If you are qualified enough to make an analysis, you will request the NABL. NABL will come and check you, and if you are qualified enough to test a product, they will give the accreditation. Now NABL. Not only NABL, we have NABL, APLAC, ILAC. These are the three international accreditation bodies that play a critical role in accreditation of testing and calibration of laboratories. So, and not only the laboratories they will test, they will also test for inspection bodies and proficiency testing providers. Okay, proficiency testing providers, PLI schemes, I have told you, right? PLI schemes in the very starting of the class. I will discuss this, don't worry. Next, what is this NABL? NABL is a national accreditation body for India. It is established in the year 1998 and it's operated under the aegis of Department of Science and Technology. So, So DST is the one which is which the Nabl is operating under. Thus Nabl provide accreditation services to the testing and calibration of laboratories. Okay, now this Nabl is under QCI, Quality Control of India. I have to mention this. Now the Nabl is under the QCI. Okay, remember this. And this Nabl operates in the accordance with the international accreditation standards such as ISO 17025. Okay, so this Nabl is under the international accreditation standards. Nabl is following which standard? International accreditation standard, which is 17025 for testing and calibration of laboratory. Now let's see the history. In the year 1973, Planning Commission suggested the Department of Science and Technology, DST, which I have told you just now, to look into the testing facilities and aspects. So for example, the planning committee told what are the needs of testing facilities and aspects in India. So they asked the DST in the year 1973. Then in 1982, based on the planning committee idea, DST set up the NCTCF, which is National Coordination of Testing and Calibration Facilities. Okay, this is set up in the year 1982. Then in 1993, it is renamed to Nabl. In 1998, Nabl is registered as an autonomous body. This is a time Nabl is established actually, because previously it is under NCT, it is under the DST. Now in the year 1998, it is registered as an autonomous body, just like FSSAI. Nabl is an autonomous body. But in 2016, this Nabl is merged into the QCI, Quality Council of India, as a constituent board, because NABCB is also in the Constitution Board of QCI. Now Nabl is also merged into the QCI. Okay, so what are the accreditation service that Nabl can do? Nabl can do 5 services. First is for testing. If you are a testing laboratory, they will give you the ISO 17025 certification. For that, you need a general requirements for computation of testing and calibrated laboratories. Okay, if you are a calibration laboratory, then also you'll get the certification of ISO 17025. If you are a medical testing laboratory, then you should follow the 15189. If you are a proficiency testing provider, which is nothing but which I have told you before, they will check the specific company and they will say whether you are qualified enough or not. It is 17043. Okay, and finally reference material producer. This also we have discussed previously, right, about a laboratory in Delhi. So they will make the reference materials. So this is 17034. See, proficiency testing is 43, it is as 34, reverse. Okay, remember this. Now Nabl. See, I have told you Nabl has got international recognition, right? How? Basically, the Nabl got signatory mutual recognition agreement with ILAC and APAC. Okay, so ILAC and APAC. ILAC means International Laboratory Accreditation Corporation. APAC means Asia Pacific Accreditation Corporation. So these two international corporation has done a MRA signatory with Nabl, which means, see guys, this is an important point, which means this reduces the technical barrier to trade. How? Basically, now Nabl report will be equal to ILAC report, will be equal to APAC report. Okay, if you got a report of ILAC, APAC, and Nabl, all the things are similar. Let's say there is a country, let's say APAC, there is a Asia Pacific country. They got a certification of APAC and they wanted to trade it to India. They don't need to get a special certification from Nabl because they already got a APAC certification. Now if you got an Nabl certificate and if you want to send the product to any Asian countries, you can follow the same Nabl certification because it will be equal to APAC. Same for international also. We already have ILAC certification, which means it is easy now. The single certification will be provided for multiple countries. So that is the reduces the technical barrier to trade. Okay, it is a global acceptance of Nabl report. Now the report has been accepted globally. This Nabl has been signatory to APAC and ILAC since 2000. Okay, since 2000. So first in the year 2000, the APLAC has only evaluated the testing and calibration of NABL. So they have only one service in the year 2000. Okay, so same, the second evaluation happened in 2004. In the year 2008, they added the medical, the third service provided by the NABL. Okay, and in the 2016 they added two more, which is PTP, proficiency testing, and RMP, reference material producer. Okay, and recently the sixth evaluation happened in the year 2021. Okay, so how to prepare for accreditation? So this is an important point in the syllabus, how to prepare it. So once a laboratory decided to seek Nabl accreditation, it should have a definite plan first. So for what reason it is obtaining the accreditation, and you should nominate a person who do all the accreditation related documentation and any other thing. Okay, that person, like for example, first plan, then nominate a person. That person will be dealing with NABL, because NABL will not entertain the consultant and advisors. Whoever the person nominated to talk with the NABL, they are the persons who has to talk. Other than that, no one else has to talk, and it will not entertain the consultants and advisors. Okay, and it also has to familiar with the quality management system, QMS. Okay, it has to be ensured with the QMS. And laboratory should be fully acquainted with the NABL documents. What are the NABL documents? I will discuss that NABL documents it's so soon, but they should have all the NABL related documents with them. Okay, now if you have all these things, then you should go for the NABL accreditation, but you should have a requirement. Okay, so what are the eligibility criteria? First is follow the 17025. Follow the ISO 17025. Second one is you should participate the proficiency testing program. As I have told you before, they should participate the proficiency testing program. If they done those things, then the third important part is they should conduct one internal audit. They should conduct themselves to check whether all the agenda points are as per the relevant standards. Okay, all the agenda points which they have mentioned in the criteria, this is as per the relevant standards or not. Okay, before submitting the application, they should check it, right? If they are given some kind of standards or reference, it should link with the NABL certifications and all those things. If it is not relevant, then they won't accept it. So they should go for an internal audit. These are the eligibility criteria. Once this eligibility criteria has been properly given, then you should go for the accreditation process. So application is given. Now they should review the document, and now they should pre-assess the document. Once they have pre-assessed the document, then they will do the final assessment. And in case of any scrutiny of the report, then the laboratory, food testing laboratory, will do the necessary corrective action. If in case they need to corrective actions, any corrective action, they can do it by root cause analysis. What is a root cause analysis? Root cause analysis means identifying the problem in the root. Okay, if any issues is there in the root, it will be identified, and based on that, it will change the necessary corrective action. Now the scrutiny has been solved. Finally, it is recommended for the accreditation by the accreditation committee, and it is approved the accreditation. Okay, once it is approved, the certification has been issued. Okay, the certification has been issued. So this is the process of accreditation by NABL. Now the certification is issued. This is the certification. This is the certification of NABL. Okay, so we can see the laboratory has been mentioned here, and what is the ISO gotten by laboratory is also mentioned, and it is a general requirement of competence of testing and calibration of laboratory. Okay, and the certification number has been mentioned here, and issue date and valid until what? So it is valid until 2023 7th, which means July. Okay, and the scope of accreditation. Scope of accreditation is also mentioned. Okay, where it is mentioned here is the scope of accreditation. See, they will mention the laboratory and the certification number and its date, and what is the scope of the laboratory. So it can do what kind of process? It can do chemical residues, and it can do food products, and it can check the fruits and vegetable products. Okay, and what is the parameters they will test it, and what is the test method they will do it. All these things will be mentioned in the accreditation. So this is the Nabl display of scope of accreditation on their website. Okay, so I have told you we need a Nabl documents in order to have the Nabl accreditation, right? What are the documents? Nabl 100A is a general information procedure, 100B is the accreditation process and procedure, 120 is the classification of products, groups in testing and calibration fields, and 131 is the terms and conditions for obtaining and maintaining the laboratory accreditation. Then 133, which is the policy for use of the Nabl symbol and claim the accreditation by the accreditation conformity. 42 is the policy for traceability of measures. 51 is the application form for testing laboratories. This is very, very important. 51 is testing laboratory, 52 is calibration of laboratory, and 53 is medical testing laboratory, and 63, okay, 53 is medical testing, 63 is proficiency testing, and finally 216 is for dealing with the adverse decisions. Okay, now you have studied about Nabl. Now let's come back to the APLAC. APLAC is a regional accreditation body which is established in 1991 under the region of Asia Pacific. Okay, headquarters is in Australia. And then APLAC provides the accreditation service to testing and calibration of laboratory. Obviously, APLAC operates in accordance with the international accreditation standards, such as it will also follow the ISO 17025. Then ILAC. ILAC means it is an International Laboratory Accreditation Corporation. 1988 it is established and headquarters is in Australia and provide accreditation to servings and testings of calibration laboratories. Okay, it will also follow the 17025. So role of this accreditation body is to provide the recognized and creditable means of accessing and certifying the competence. So this is nothing but what is the role of ILAC, APAC, KAPAC and Nabl, which means they will recognize a good laboratory and they will certify them. That's it. That's their role. They will recognize testing laboratory, calibration laboratory, inspection, proficiency testing providers, and they will certify them. They will recognize and they will certify. That's it. Nothing else you need to study. Okay, so let's come to this part, direct part, which is ISO 17025 and its general requirement. See, we need to follow this ISO 17025 in order to get the certification. So what are the general requirements? First requirement is QMS, quality management system, and technical competence and impartiality, accurate traceable measures and verify reliability of the test results, appropriate test and calibration methods, and testing and calibration method is calibrated, maintained and used correctly. See, all these things, it's a requirement, so you need to record this in the documentation. If they check this, reporting the results and traceability of the data, sampling and handling of tests, control of non-conformity testing, and continuous improvement of laboratory technical competence and quality management systems. Okay, if any QMS has to be improved, it should be improved. Okay, then documentation and prerequisite. To attain the ISO 17025, we need some few documentation prerequisite. Okay, so I have considered a chemical testing laboratory. Okay, in this case, so to attain the ISO 17025, what are the requirements is there? First is quality manual. Let's say, I have taken the example of chemical testing, right? Let's say if you want to do a proximate analysis, you should know what is the manual which you are going to follow to test the proximate analysis. That manual will be documented. Okay, so this manual which include QMS system, policies, procedures and process of ensuring the competence and impartiality of the laboratory work. Second one is a procedure. How to do the specific analysis. So the laboratory may have a procedure for properly storing, handling and disposing of hazardous chemical. I have given example of chemical testing laboratory, right? So this is an example. Then personal. See, let's say I have a chemical testing laboratory and microbial testing, microbial food analyst is a person I got. Will that be okay? No. I should have a proper chemist to do the role. That is a personal. And the equipment, same. I should not conduct the equipments which is not related to chemical analysis. So in case if I need a spectrophotometer, it should be calibrated and ensure it is in proper result. So I should buy the equipments and calibrate it according to the need of my laboratory. Calibration reference standards. You should have a proper calibration reference standard, which has been discussed so many times. And test methods, how to test it. So this is also simple. And sample management, how to make the sample. See, in case of HPLC, you need to make the sample differently, and in case of GC, you need to make the sample differently. So preparing the sample is it's a key part. So you should have a proper knowledge about how to manage the sample. Results and traceability. So this is we have discussed so many times. Laboratory may have the database of stored test results, so they will check it with the they will check it with the previous samples and test results. Okay, non-confirmatory work. Non-confirmatory work means identifying and investing the document and non-confirmating testing work. For example, say let's say take an example. Okay, so let's say you are a laboratory and you want to do proximate analysis. Okay, and you have you have all the equipments to do all the work, but except you wanted to check volatile fatty acid test, but you don't have a facility to check the volatile fatty acid. You have the technology to check the total fatty acids, but volatile fatty acid you don't have specific let's say chemicals or equipments to test it. So that is the non-conforming work. Okay, so they should mention if any non-conforming work is there, and this is out of the scope, outside of the expected range. So they should mention if they have any non-conforming work which is there. And continual improvement. If for example in the next month or next year, I should be having like if I have a proper let's say amount or something, if they have a proper investment or something, then I will do this procedure. In next year I will do the volatile fatty acid test also. I can make the equipment which can do this process also. So that is a continual improvement. Then now the basic requirement is over. Now the management requirements. Management requirements, first is QMS, technical competence, impartiality. This is simple. Technical requirements means accurate test results, validity and reliability of the results, appropriate test and calibration methods, calibrated and maintained equipments, sampling, reporting of results, confirm. The points will be similar. And I have given an example. Okay, let's discuss this example. See, if I wanted to do electrical testing laboratory, then what is the what kind of management techniques I need to know. First is we need to make a QMS, which is including the controlling and improving the process, quality management system, right? Then we should ensure the personnel which can able to control the responsibility of electrical testing. Then testing and calibration of laboratory activities will be there, and appropriate validate test will be there, properly receive, handle and store the test samples. Okay, and meeting the 17,025 2017. So these are some simple things. Final and last line which you need to know is measurement of traceability. So what is a measurement of traceability? In the context of food testing, when we say food measurement of traceability, we should know that, see, we have a test result which is a known value. So this known value is a test result. Okay, which is a test result which is similar to the reference value. So we can compare and say this is traceable. This is the measurement of traceability. Okay, I have given an example here. See, the tin has a residue of canned food. We should not have tin more than 250. Okay, the residue of tin should be less than 250 in case of canned food. So this 250 value is given in the contamination regulation FSSI. So check that. So this I will take as a reference value. So I will compare my known value with the reference value which is traceable to one another. Okay, so the concept of measurement of traceability is essential in the food testing, as it ensures the results produced by the laboratory are of known accuracy and can be relied upon. Okay, accrediting bodies use this measurement traceability to determine the competence of food testing laboratory and ability to produce the accurate test results. In addition, regulatory bodies such as food safety authorities may require measurement traceability to support the compliance of food safety regulations and standards, which means this is not only to test that whether the food testing laboratory is doing good work or not. We can also use this as support complaints, which means if FSSAI has let's say legal defensibility, if that takes a legal defensibility about food safety food business operator in a specific product, whether he is responsible for adulteration, then he can go to like he can will be responsible for penalty or punishment. Then FSSAI will use this data, will use this let's say measurement of traceability to mention that this is what happens in the like this is the standard reference, and this is what we compared in order to say that that person will be responsible for penalty and punishment because he is adulterated. Okay, so yeah, that's it. We have completed the topic, 3 important topics. Okay, I haven't discussed these MCQs, okay, because it will take, already it is like 1 or 30 minutes. So yeah, I'll end this topic now, and I will give you, there is one competition. Okay, one competition. See guys, if you go to the comment section, we have given you 10 questions. It will be pinned, don't worry, it will be pinned. So whoever is giving the proper answer for all the 10 questions, right, we will mention the person, like the first person to give the right answer, we will give a shout out to the person in the next video. Okay, so yeah, so this is just a simple gesture of us, like because obviously like you are preparing this so eagerly, so we wanted to make some like fun quizzes out of it. So yeah, that's it. One second. So yeah, that's it. So yeah, so that's it. So let's meet in the next class.